return to more hardware on Modern Marvels. The Modern Hardware store offers one-stop shopping for every type of rope needed for tying and pulling and wrapping and cinching. Some ropes today are almost as strong as steel cable and can withstand enormous amounts of pressure before breaking. Once it's manufactured, rope is often sent to independent testing companies, like Tension Member Technology in Huntington Beach, California, to be evaluated.
They're interested in having a disinterested third-party laboratory run tests for them so that they get an unbiased view of rope performance.
One of the most important tests measures the actual endurance of a rope over long periods of time.
The object of the game for this test is to run the rope specimens for a certain number of cycles, and after testing a number of pairs of samples, we can then determine how the rope strength degrades with increasing numbers of cycles.
The test can last for several months, 24/7. Perhaps the most important test involves the tensile strength of a rope.
Tensile strength is a rope of new construction under normal conditions being tested for the absolute maximum strength that it will break at.
Going to run a breaking strength test now on a 3-strand nylon rope. What we're doing at the moment is taking the slack out of the rope, giving it a slight pre-tension, and then we'll pull it to break.
The tensile strength rating of each rope has a large safety margin built into it.
It says the safe working load is 100 pounds. You would not want to use it at loads more than 100 pounds. The true breaking strength of the rope is probably 10 times that. But you need that safety margin because as soon as you begin to use a rope, it begins to degrade, begins to wear out.
Rope has developed over thousands of years. It's one of our oldest tools.
I would say that rope probably was invented before wheels.
Early ropes were made of fibers extracted from the leaves and stems of such plants as manila and sisal, or from the hide and hair of animals. Most ropes have at least 3 strands of fibers twisted together.
The best way to look at the twisting process is that it's kind of a foundation. In other words, it holds the fiber together. You twist part of the rope, the strand, one way, and the other part of the rope the other, so it's trying to collapse to the middle. That keeps the bundle snug or tied together so that it then can be used as twisted rope.
The ancients learned this lesson early and used rope when building structures that were to become wonders of the world.
Rope was used to make the pyramids. The Egyptians had used rope twisted from papyrus on the banks of the Nile, and they would use that to drag those giant blocks from the quarries to where the pyramids were constructed.
Across 6,000 years of sailing history, ships relied on ropes made of natural fibers, like hemp and manila. The world of rope was revolutionized during World War II with the introduction of synthetic fibers. This change came about when the Japanese seized the major growing areas of natural fiber plants, forcing Allied scientists to come up with something new and innovative.
During World War II, almost all rope was hemp or manila. Well, once the Philippines were seized, how do you make rope? What do? You don't have rope.
Synthetic rope fibers are a byproduct of petroleum research.
You take a barrel of oil and you break it down into its basic building blocks, and then you create these pellets or resin.
Synthetic ropes have proven to be much more effective than those made of natural fiber.
Those fibers, a nylon fiber or a polypropylene fiber, have more strength than the natural fibers like manila or sisal. They're not affected by weather. They have greater durability.
Ropes are often custom-made to the exact specifications of a buyer, like this special order polypropylene rope being manufactured by the Bevis Rope Company. It all begins with the pellets. In the mixing bin, they're combined with other ingredients to create the exact rope formula specified by the buyer.
We start putting the cocktail together. We add the color concentrate, we add some special chemicals in terms of lubricity, UV stabilization, abrasion resistance.
The pellets are next transformed into rope fibers in a machine called an extruder.
It goes into the back of this machine at about 90 degrees Fahrenheit. It comes down through the machine. This is a corkscrew in here, and what this corkscrew does is it comes down through the machine, it increases the pressure and the temperature.
As the pellets are pushed, their temperature is increased dramatically by a series of heat bands. The corkscrew augments this heat by compressing the pellets tighter and tighter, creating friction that raises their temperature even more. By the time they reach the end of the machine, their temperature has risen to 490 degrees Fahrenheit, and they've been transformed from resin pellets into molten plastic.
As they come out and drop into this water bath, we put it in water so that we can touch them again. Otherwise, they're sticky and they would stick to each other. Those fibers are then separated. Then we go through some air blowers to get all additional water off. Then these fibers goes into this set of rolls. This set of rolls does two things. It pulls the fiber out of the machine. The pressure pushes it, and then this pulls it. But this also serves as a braking set of rolls for the next process, which is spinning 6, 7, 8, or 9 times faster. So this fiber now under severe tension, incredible tension now, goes into this oven. We take it back up to 350 degrees, and it's in this oven that we are stretching the fiber and giving it its set or its tensile strength.
The stretching of the strands is the most important part of the process, because it's here the manufacturer creates the desired strength of the rope. The strands are stretched anywhere from 4 to 8 times. The more they're stretched, the stronger they become. This is because the stretching activates molecules in the rope fibers, causing them to bond more and more strongly each time they go through the rollers. When the desired strength is attained, strands are moved on to the next part of the process, where they're wound onto bobbins. The bobbins are next taken to a machine that twists the fiber strands. Then it's off to the rope-making machine.
This is where it all comes together. This is where we make rope. We extruded the yarn, we twisted the fiber, we put this fiber in the bed. That fiber comes forward over here and forms 3-strand rope. You have 3 separate strands, and those 3 strands form 3-strand rope. It goes up here through a set of drive capstans or pulling capstans, because it's operating under severe tension and pressure, and that's where we make the rope. In this case, it's yellow polypropylene rope.
And that's how you create a strong and durable rope. Now you're ready to tie things up. But what if you want to lock things down? Locks and keys are one of the main reasons people visit hardware stores. High-strength synthetic ropes may survive more than 6 million cycles during laboratory endurance tests before breaking. More hardware will return on Modern Marvels.